In this video, we're going to talk about drawing resonance structures with OscerSketch, and in particular, how to answer a Oscar dot question. So here's a sample quiz. Question 1 says you are supposed to draw the second resonance structure of the acetate anion, which is shown here. How do you do that? Well, there's special rules for drawing Oscar dot problem answers. So you click on Create Oscar dot Answer. And the interesting thing is here, if you look at OscerSketch, is lost a lot of its functions. And in fact, where are the elements? You can't draw a new compound. All you can do in an Oscar dot problem is duplicate what you were given to start with. So let's duplicate the first structure. And of course, this is going to serve as the basis for our second resonance structure. The whole idea is resonance structures, you have to have the same atoms in the same places. So the program doesn't allow you to move them because that's illegal when drawing a resonance structure. You have to keep the same structure. So in terms of the framework of the elements, you can't move atoms around. So here's the same framework, but what we can do is change the bonds and the lone pairs, the charges. So we know that in the other resonance structure here, we got to switch the locations of the single and double bonds. So let's do that. We'll make this top double bond a single bond. We'll make that what was the single bond the new double bond. Now we got to get our charges right. There's no longer a minus charge on that bottom carbon. The minus charge is on the top oxygen. Top oxygen. So the charges are right now. Now we have to do the lone pairs. The top one needs one more lone pair. The bottom oxygen needs to get rid of a lone pair. We're at 3. The way to go to 2 is you click once more, you go to 0, then 1, then 2. So that's our answer. It's as simple as that. So we simply save the answer, close, and we can submit over here, and indeed we're correct. Good thing. So let's just look briefly what you have to do for the other ones. This one, you have to draw 2 resonance structures for this nitro group. Well, there's no lone pairs of double bonds, but there are lone pairs of double bonds. You're going to have to put them in. So what you'll do is duplicate this molecule and work out where the lone pairs and where the charges are. It's a little tricky. Nitro group's a little bit different than other things. Here's a real chemical reaction, is that this is acetone. It's a ketone, and if you use hydroxide, a very small amount of acetone will be deprotonated. The equilibrium constant is way to the left, but a tiny amount will be deprotonated, and you'll form this anion. But this anion is not the best resonance structure. There's a much better resonance structure, and when you open Oscar, the dot problem, you'll see this structure. You'll have to again figure out a better way to draw a resonance structure where you move that negative charge around. And then the last problem is you're going to protonate. This is an amide. Now, if I asked you where you protonate an amide, you'd probably tell me the nitrogen. Well, if you told me the nitrogen, you'd be wrong, because the oxygen gets the proton. Why is this? Well, if you protonate the nitrogen, it screws up the resonance. Protonate the oxygen, resonance is still intact. And this is what this is all about. Here is this is the Lewis structure of the protonated amide, but there's a better one, and you have to draw the second resonance structure. So these are pretty simple problems, but they're good practice for drawing resonance structures, and I think you can get the hang of it really easily.